The air in the Peruvian highlands is thin and crisp. Here, nestled high in the Andes Mountains lies a fortress of truly monolithic proportions. It is called Sacsayhuaman. Its walls are a staggering jigsaw puzzle of stone. Some individual blocks weigh more than 100 tons. They are fitted together with astonishing precision. Not even a single sheet of paper can slide between them. How could a civilization, one without the wheel for transport, or iron tools for carving, possibly achieve such a feat? This question has echoed through the centuries, a quiet yet persistent mystery. It challenges our understanding of the ancient world. It is a testament to human will, and to engineering that still puzzles us. Standing before these colossal walls, one feels an overwhelming sense of awe. The stones are not uniform. They are not simple bricks stacked one upon the other. Instead, they are complex polygonal shapes. Each stone is unique. They interlock with their neighbors in a seamless organic embrace. It is as if the rock was made soft, molded, then hardened. The sheer scale is staggering. The challenge these ancient structures present to modern engineers is one of both scale and precision. We today possess cranes that can lift hundreds of tons and laser-guided cutting tools that can achieve microscopic accuracy. Yet, the prospect of recreating a site like Sacsayhuaman or the Great Pyramid of Giza using only the tools believed to be available to ancient cultures is a daunting one. The Great Pyramid, for instance, is composed of an estimated 2.3 million stone blocks, most weighing several tons each. These were quarried, transported, and lifted to heights of over 400 feet. The sheer logistical operation required to manage such a project, without modern computation or machinery, is almost inconceivable. Engineers look at the problem from a practical standpoint. They consider the tensile strength of ropes, the friction of moving heavy objects over sand, and the stability of immense ramps made of earth and rubble. For example, some theories about the construction of the pyramids suggest long, straight ramps. However, a ramp reaching the top of the Great Pyramid would have to be over a mile long, requiring a volume of material nearly as great as the pyramid itself. Other theories propose spiral ramps, but these would have made it incredibly difficult to maneuver the large blocks around tight corners. At sites like the Serapeum of Saqqara in Egypt, we find enormous granite boxes weighing up to 100 tons including their lids. These boxes are carved with perfectly flat surfaces and sharp, right-angled corners, both inside and out. This phenomenon of inexplicable ancient engineering is not confined to one or two locations, it is a global one. Far across the Pacific Ocean on the isolated outpost of Easter Island, stand the silent moai. These giant monolithic statues, some towering over 30 feet high and weighing over 80 tons, were carved from solidified volcanic ash. The mystery here is not just their carving, but their transportation. How did a small, isolated population move these colossal figures for miles across the island's rugged terrain, and then erect them onto ceremonial platforms? Half a world away, in the sun-baked landscape of Lebanon, lies Baalbek. The Roman temples built here are magnificent, but it is what lies beneath them that truly defies logic. The foundation platform contains some of the largest worked stones on the entire planet. Known as the Trilithon, 3 of these stones weigh an estimated 800 tons each. They were quarried over half a mile away and lifted into place nearly 20 feet off the ground. Nearby, still in the quarry, lies an even more monstrous block, the Stone of the Pregnant Woman, which is estimated to weigh a staggering 1,200 tons. Even our most powerful modern mobile cranes would struggle to lift such a weight. Then we travel to Bolivia, to the high-altitude plateau of Pumapunku. Here, scattered across the landscape like a giant's discarded building blocks, are pieces of andesite and diorite stone. What is so astounding about Pumapunku is the precision of the work. We find stones with perfectly straight edges, complex interlocking shapes, and holes drilled with machine-like accuracy. Faced with these enduring enigmas, experts have proposed a wide spectrum of explanations, ranging from the steadfastly conventional to the wildly speculative. The mainstream archaeological view holds that human ingenuity, combined with limitless time and a massive organized workforce, is sufficient to explain these marvels. Proponents of this view conduct experiments demonstrating how, with enough people and simple machines like levers and rollers, large stones could indeed be moved. They argue for a deep generational knowledge of stoneworking, passed down through millennia, allowing artisans to achieve incredible results with seemingly primitive copper and stone tools. They believe we simply underestimate the patience and resourcefulness of our ancestors. However, these explanations, while plausible for some aspects, often fall short of explaining the most extreme examples of precision and scale. One compelling idea is the existence of lost ancient technologies. Perhaps ancient civilizations had discovered chemical processes to soften or dissolve stone, allowing it to be poured into molds and then rehardened. Others have theorized about the use of sonic energy or acoustic levitation, harnessing the power of sound and vibration to lift heavy objects, a concept hinted at in some ancient myths and legends. The idea of ancient astronauts, popularized in the 20th century, suggests that extraterrestrial beings visited Earth in the distant past. In this view, beings with advanced technology either built these structures themselves or gifted the knowledge to early humans. What then do these magnificent, logic-defying structures teach us? They serve as a profound and humbling reminder that the story of humanity is far from complete. They challenge the linear narrative of progress, the simple idea that we are cleverer and more capable than every generation that came before us. These stones, silent and immense, suggest that capabilities can be lost as well as gained. They hint at peaks of technical achievement in our deep past, followed by valleys of forgotten knowledge. Our history may not be a straight line of ascent, but a complex tapestry of cycles, with forgotten golden ages and lost arts. These mysteries fuel our innate human curiosity. They are the engine of discovery, pushing archaeologists to dig deeper, engineers to test new theories, and all of us to look at the past with a sense of wonder. To dismiss them as simply solved by invoking immense manpower is to perhaps do a disservice to the true genius of their creators. The enduring questions are what make these places so special. They transform them from mere historical ruins into active living puzzles. Perhaps the most important lesson is a celebration of human ingenuity in its purest form. Whether Sacsayhuaman was built with brute force, lost science, or some other means we cannot fathom, it was born of a powerful creative impulse. It represents the desire to shape the world, to leave a mark that will endure for millennia, to build something that reaches for the eternal.